Okay, am I audible?
Yes, sir.
Okay, thank you. Okay, now let me introduce myself. My name is Chandan Kumar Gupta. I'm a research scholar in Department of Mathematics, IIT Patna. I'm your NPTEL PMRF TA for the course Probability and Statistics. This course is offered by Professor Somesh Kumar sir. He is a faculty in IIT Kharagpur. Okay. If anyone wants to ask anything regarding the previous lectures, they are free to ask. Okay. So this is the 6th week of the 12-week course. And in this course, like we are mainly going to deal with joint distribution. And then mainly joint distribution is like there are different type of joint distribution like bivariate normal, bivariate gamma, beta, and uniform. There are many joint distributions are there. But in this week, we are mainly concerned on bivariate normal distribution. Okay. And then we will solve some problems related to bivariate normal distributions. Okay. So, okay, let's start. Okay, in joint distribution, like what? Suppose till now we are dealing with the univariate distribution, in which a random variable like x or y, like x or y or z, any variable that follows that is like the height of a student, the weight of a child, and something. Suppose we want to deal two or more than two variables simultaneously, then we will go to joint distributions. Okay. Suppose here for joint distribution, we have considered two variable x and y. Okay. And x and y are jointly distributed random variable. It is in paired form. Suppose it is the height and it is the weight of a child. Well, height and weight of a child. Okay. Then we will study about collect simultaneously. Then it is a jointly distributed, and the CDF is written like this. Okay. And different kinds of joint distribution, as already said. Then we'll mainly concern on bivariate normal distribution. Okay, bivariate normal distribution, like the PDF of the bivariate normal is like this. Suppose xy follows bivariate normal distribution with PDF with parameter mu1, mu2, sigma 1 square, sigma 2 square, and rho. Here mu1 and sigma 1 is the mean for x random variable, and sigma 1 is and mu2 and sigma 2 square is the mean and variance of the y variable, and rho is the correlation coefficient between these two variables. Okay, so like the PDF can be written as it's 1 upon pi. These are already covered. I'm just trying to recall something. Okay, sigma 1, sigma 2, 1 minus rho square e to the power like minus of 1 upon twice 1 minus rho square, and then it's x minus mu1 upon sigma 1 square plus y minus mu2 upon sigma 2 square, and then minus of twice of rho x minus mu1 upon sigma 1, y minus mu2 upon sigma 2. Okay, so this is the probability density function for the bivariate normal distribution. Okay, so bivariate normal distribution have different properties, like from this distribution or this equation or this PDF, we will calculate the marginal of x and marginal of y. That can be calculated as well. How? Like fx, which is integral over when we calculate like we need to calculate the marginal distribution of x, then we will integrate the joint distribution with the range of y. Okay, and we see that here x follows like normal distribution with parameter mu1 and sigma 1 square. Also, in the same manner, the marginal PDF of y can also be evaluated like this, and we will find out mu2 sigma 2 square. Okay, and one more thing, like conditional. Yes, as we know that, na, like probability of A given B equals like probability of A intersection B upon probability of B. Conditional probability. In the similar manner, we can calculate the conditional distribution. So, like f of x given y equal to y, this can also be calculated, and this can be calculated as like f of the joint PDF, like bivariate normal distribution PDF, which is like this, and given condition is y. So we can divide the marginal of y, and we will find out it is also a normal distribution, and x given y equal to y, it follows normal distribution again, but with like its mean is mu1 plus rho sigma 1 and then y minus mu2 upon sigma 2. It is the mean of the conditional distribution x given y, and then variance is like sigma 1 square 1 minus rho square. Also, in the same manner, the distribution y given x equal to x can be evaluated as this. It is also a normal distribution with mean mu2 plus rho sigma 2 x minus mu1 upon sigma 1, and this is sigma 2 square 1 minus rho square. So from here we will see that like when we have bivariate normal distribution, okay, so it's a marginal densities x and y is also normally distributed, and its conditional distribution is also normally distributed. Okay, so that means we have a theorem like this. Suppose x and y are bivariate normally distributed, then all its marginal and conditional is normally distributed. And also conversely, we will say that if we have marginals of the variables is normally distributed and their conditional is also normally distributed, then the joint PDF of these variables is a multivariate. Suppose we are dealing with 3, 4, then multivariate normally distributed random variables. Okay, we can say like this because when we have joint distribution, then we will able to evaluate the marginal distributions of variables. But in case of marginals distribution, we are not able to calculate the joint distribution until and unless we have given some other conditions. Okay. Okay. Then after that, yes, here like suppose like we have written x y follows bivariate normal distributed with mu1 mu2 sigma 1, sigma 2 square, and rho. These are the parameters for the bivariate normal distribution. So here we can tell that expected value of x is mu1, expected value of y is mu2, variance of x is sigma 1 square, variance of x2 is sigma 2 square, and this is the correlation between x and y is rho. Okay, and what is the correlation? Can anyone define correlation? Anyone? Okay. Like correlation is defined as the measure of linear association between the variables. Okay, here we are dealing with two variables, x and y. So we want to measure how x and y are linearly associated with each other. Then we will evaluate the correlation coefficients. Okay, it lies within -1 to +1. The range of rho is lies within -1 to +1. That means if rho equal to 1, that means it is totally or completely linearly associated with the other variable, like this, x equal to here x is directly or completely related to b in a linear manner. Okay, so here it is either +1 or -1. That depends on either it is completely related but in same direction or in opposite direction. Okay, so correlation gives the linear association between the variable. Okay, it gives the linear association. Okay, and also wait. Yes, and correlation can be calculated as correlation of two variable x y. It is defined as covariance between the two variable x and y divided by sigma x, sigma y, or sigma 1, sigma 2. Okay, so how can we calculate covariance? Covariance of xy. It is defined as the expected value of xy minus expectation of x into expectation of y. Okay, and in case of bivariate normal distribution, since we know that the correlation is covariance of xy equal to what? Correlation between x and y into sigma x, sigma y. So that is covariance between the two variable x and y in case of bivariate normal distribution is rho sigma x, sigma y, which is the standard deviation of variable x and y respectively. Okay, and then okay. Now MGF, like MGF of bivariate normal distribution, which is defined as the expected value of e to the power tx for univariate, so expectation of sx plus dy, and it is calculated as exp to the power, it is mu1s plus mu2t plus half of sigma 1 square s square plus half of sigma 2 square t square, and then plus of rho of sigma 1, sigma 2 s and t. This is the moment generating function for bivariate normal distribution. Okay, and similarly, like we will transform those x and y follows bivariate normal with mu1 mu2 sigma 1 is square sigma 2 square and correlation coefficient is rho. That means y, which is a variable of not y, we have already considered y here. So suppose z, which is ax plus by. So linear combination of two normal variables. It is also a normally distributed random variable with a parameter a mu1 plus b mu2, and the variance is like a square sigma 1 square plus b square sigma 2 square plus 2ab rho sigma 1 sigma 2. So this is the mean and the rest one is the variance for z. Okay, so these are some of the properties. These are already there in the lectures. Okay, so we will mainly solve some numericals related to these properties or bivariate normal distributions. Okay. If any doubt, you may ask me directly anytime. Okay, then we will start with question number 1. Is it clear now? Am I audible now clearly?
Yes, sir.
Thank you.
Yes, sir.
Okay, thank you. Okay, then from question number 1, like here it is given, we need to calculate the probability that x is less than 1 or equal to y is less than or equal to 3 and x plus y is less than or equal to 4 for a bivariate probability distribution of xy, and the distribution is given like this. Okay, this is the bivariate probability distribution. Okay, so this is a first, it is a discrete. Okay, it is a discrete probability joint probability distribution. Here the x ranges from 0 1 and 2 and y ranges from 1 to up to 6. Okay, so from like we need to calculate probability that x is less than or equal to 1. That means we need to calculate the marginal of x first, and also marginal of y is there because we need to calculate y is less than or equal to 3. So probability that x equal to x, that is marginal of x, can be evaluated as summation probability that x is equal to x, y equal to y, and the summation is taken over the, we need to calculate x, so we will take the summation over y. So from here we can calculate something like this for y equal to 1, y equal to 3, 4, 5 and 6, and from this table we will evaluate this like this. Okay, because it is the value of x for which all values of y is given, and then we will take summation. Okay, so 0 plus 0, 1 by 32, 2 by 32, 2 by 32, 3 by 32. That means 2, 2, 4, 4, 8. That is 8 by 32. 8 by 32. Probability that x is equal to 0. It is probability that x is equal to 0. Then at x is equal to 1, it is 1 by 16 plus 1 by 16 plus 1 by 18, 1 by 8, 1 by 8, 1 by 8, 1 by 8. Okay. So it is 10 by 16. That is 5 by 9 or 10 by 16 I can write. Okay. And the third one is like 1 by 32, 1 by 32, 1 by 64. Sorry. 1 by 64 and 2 by 64. 2, 3, 4, 8. That is 8 upon 64 or 1 by 8. You may write. Okay. And you may see that when we take summation, suppose when we take summation over x, then it is 8 upon 32 plus it is 10 upon 16, or we can write 8 upon 64. It is 64. It is 16 plus 40 plus 8. That is 64 upon 64. That is 1. So that means this is the marginal PDF, marginal probability mass function for random variable x. In the same manner, when we need to calculate like the y, the joint PDF, so marginal PDF of y variable, then we will take the summation over x, the joint random variable. Okay, so here for x, different values of y, we will take this. So is written like this. So we can calculate 1 by 16 plus 1 by 32. It is like 3 by 32. It is also 3 by 32. And this is, it is 8, 10, 11. 11 upon 64. It is 12 upon 60, 13. It's 13 upon 16, 4. And it is 32, 4 to 6 upon 32. The last one is C1 to 64. 10, 6. 16 upon 64. And when we take the summation of this, it is also comes out to be 1. Okay, that means these are the proper distribution. Okay, proper density function. Okay, now we have PDF of x, like PMF or PDF, both are same thing in case of the nature of the variable. PDF of x and PMF of y. So we need to calculate, the first one is probability that x is less than or equal to 1. That means probability that x equal to 0 plus probability that x equal to 1. So probability that x is equal to 0 is this, which is equal to 8 upon 32, plus probability that x equal to 1, which is 10 upon 16. This can be evaluated like 32, 8 plus 20. Okay. It is 28 upon 32, which is also 7 by 8. Okay, so we are able to calculate the probability value. Also, now for y is less than or equal to 3. Okay. Probability that y is less than or equal to 3, and range of y is 1, from starting from 1. So that means probability that y equal to 1 plus probability that y equal to 2, y equal to 3, and up to 3. So probability that at y equal to 1, it is 3 upon 32. Y equal to 2, it is also 3 upon 32. And at y equal to 3, it is 11 upon 64. That means 3 upon 32, 3 upon 32, plus 11 upon 64. And it is like 64. 6 plus 6 plus 11 is 23 upon 64. This is the answer for probability that y is less than or equal to 3. Okay. Now we need to calculate a probability that x plus y is less than or equal to 4. Okay. We need to calculate probability that x plus y is less than or equal to 4. So this can be calculated. We need to calculate the value of y and x. We need to calculate the pair. Okay. So first, x plus y is less than 4. That means x equal to 0, y equal to 1. X equal to 0, y equal to 2. X equal to 0, y equal to 3. And x equal to 0, y equal to 4. then x equal to 1, y equal to 1, x equal to 1, y equal to 2, 1, y equal to 3, 2, y equal to 1, x is equal to 2, y equal to 3, and only these 4, 9. There are only 9 conditions are there for all values of x equal to 0, y equal to 1, 2, 3, and 4. X is equal to 1, y equal to 1, 2, 3. X is equal to 2, y equal to 1, 2. Okay, so we need to calculate this probability. Okay, so that means probability that x equal to 0, y equal to 1 plus probability x equal to 0, y equal to 2 plus probability 0, y equal to 3 plus probability 0, y equal to 4 plus these all are probability x equal to 2, y equal to 2. Okay, so from here 0 plus 0 plus 1 by 32 plus 2 by 32. So 0 plus 0 plus 1 by 32 plus 2 by 32. Okay, in the same manner 1 by 16, 1 by 16, 1 by 8. It is 1 by 16 plus 1 by 16 plus 1 by 8. And 1 by 32 plus 1 by 32, 1 by 32 plus 1 by 32. Now this can be solved. We will take 32 as a LCM. 1 plus 2 plus 2 plus 2 plus 4 plus 1 plus 1. This comes out to be 13 upon 32. Okay. Any doubt in this question? We will check the pair for which this relation is hold, and these are the 9 possible conditions for the variables x and y. So this can be evaluated like this. Okay. Now on the second question. Here the joint density function of random variable x and y is given by is k times of 2x plus y for the value of x is 0, 1, 2, y is 0, 1, 2. It is also is again discrete random variable. We need to calculate the value of k, marginal distribution of x and y, and the conditional distribution of x and y. Okay. So also again, like it is a PDF, that means the summation probability that should be equal to 1. So from here, like we will take summation x equal to 0 to 2, y equal to 0 to 2, k times of 2x plus y equal to 1. Okay. Then putting the values like x is equal to 0 to 2, then put the value of y, it is 2x plus 0 plus 2x plus 1 plus 2x plus 2 equal to this. So after solving this, we get x equal to 0 to 2, k times of 2x plus 2x plus 1 plus 2x plus 2, it is 6x plus 3 equal to 1. Now putting the values of x again, so k times of 6 into 0 plus 3 plus 6 into 1 plus 3 plus 6 into 2 plus 3 equal to 1. It is 3 plus 9 plus 15 equal to 1. That means K, it is 27 equal to 1. This implies K equal to 1 upon 27. So the value of K is 1 upon 27, for which this given function is a joint density. Okay, because it is the okay. Now we need to calculate the marginal. Okay, so marginal can also be calculated now. Like marginal of x is what? Summation is taken over y is from 0 to 2, and k is 1 upon 27, and it is 2x plus y. Okay, so we put the value like okay, 1 upon 27, it's 2x plus 2x plus 1 plus 2x plus 2. Probability that x is equal to 1 upon 27 is 6x plus 3, or x equal to 0, 1 and 2. So probability that x equal to 0 is 1 upon 27. 6 into 0 plus 3, that is equal to 3 upon 27, which is equal to 1 upon 9. Similarly, probability that x equal to 1, which is equal to 1 upon 27, 6 into 1 plus 3, which is equal to like 9 upon 27, which is equal to 1 upon 3. And probability that x is equal to 2, which is equal to 1 upon 27, 6 into 2 plus 3, which is equal to 15 upon 27, which is equal to 5 upon 9. Okay, so after summation, we will get like probability that x equal to 1, 1 by 9 plus 3 by 9 plus 5 by 9. Okay, so this is the value for marginal distribution of x. Okay, similarly, we need to calculate the y also. So probability that y equal to y, it is taken summation over x, which is also from 0 to 2, and it's 1 upon 27, 2x plus y, which is equal to like 1 upon 27. Consider x is equal to 0, then it is 2 into 0 plus y plus 2 into 1 plus y and 2 into 2 plus y. So solving, we get 1 upon 27, and it is y plus 2 plus y plus 4 plus y, which is 1 upon 27, and it is 3y plus 6. Okay, so this is the marginal PDF for y equal to 0, 1 and 2. Now we can calculate the value of y equal to 0, which is equal to 1 upon 27, 6 into 0 plus 6, which is equal to 6 upon 27, or 3 upon, not 3, it's 2, 2 upon 9, or probability that y equal to 1. It is like 1 upon 27, 6 into 1 plus 6, which is equal to 12 upon 27, which is equal to 4 upon 9. The last one is probability that y equal to 2, which is equal to 1 upon 27, 6 into 2 plus 6, which is equal to 18 upon 27. It can be written like 2 by 3 or 4 by 9. I think there is some mistake. Can anyone tell me? Yes. Why do I write it? 3? It's 3 times, na? So it is 6 plus 3. It is 9. And it is 12. So similarly, it is like it's like 1 by 3 or 3 by 9. It is like 4 by 9. And the sum is also equal to 1. Okay. So we will like value of k is evaluated, marginal distribution of x and y is evaluated. Now we need to calculate the conditional distribution of y given x equal to 0. Okay. Now we need to calculate conditional distribution of y given x equal to 0. Okay. So this can be calculated by probability that x equal to 0, y equal to y, and divided by probability that x equal to 0. Okay. So probability that x is equal to 0. So we can like create a table. Okay. So y has 3 values like 0, 1 and 2. And this is probability that x equal to 0, y equal to 0 divided by x equal to 0. Similar manner, we can write like probability that x is equal to 0, y equal to 1, y equal to, not y, it's x is equal to 0. And probability that x equal to 0, y equal to 2 divided by probability that x is equal to 0. Okay. So probability that x is equal to 0, y equal to 0, 0, 1 and 0, 2. From here, from the main table, or not from the table, we have constructed the table. Okay. Okay, we can directly write here like this. After like we have a distribution like 1 upon 27, 2x plus y. Okay. When we put the value of x and y equal to 0, 0, it is like 1 upon 27. Is it? Or I am checking somewhere. Let me check. Yes.
I think
It's 1
zero value of
0, 0. Yes.
0 at 0 we get
Yes.
to
It
0.
turns out to be 0. Yes. 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 Thank you. Thank you. Because the numerator terms is 0, na? Because 2x plus y, it is 0, it is 0, then overall value is 0 divided by, and x is equal to 0 is here, we have already calculated 1 by 9. So it is a like 0 upon 1 by 9, which is comes out to be 0. And for x is equal to 0, y equal to 1, it is 1 upon 27 divided upon 1 upon 9, which is a 1 by 3. Okay. And x is equal to 0, y equal to 2 is 2 by 27, and divided by 1 by 9, it is 2 by 3. Okay. So these are our values. Okay. So probability that y given x is equal to 0 is, or y equal to 0 this, y equal to 1 this, and y equal to 2 this, and taking summation, we will get probability equal to 1. That means it is a proper distribution. Okay. So this can be calculated also like, okay. Okay. If anyone have any doubt, he or she may ask. Now question number 3. Here the joint density function of a random variable x and y is given by this. We need to calculate the expected value of x plus y. Okay. So given PDF is like this. Expected value of x plus y. Here x and y both terms are there. That means it is integral x plus y fxy dx dy. If we will take dx first, then the range of dx is written first, which is 0 to infinity, and y has also the same range. So both have the same meaning here. That means 0 to infinity, 0 to infinity, it's x plus y. It is e to the power minus x minus y dx dy. Okay. So we first take x. It is a simple integration, I think. No? Just try to do this. I'm also doing. Okay. So first, like 0 to infinity is taken here, and e to the power minus x minus y can be written as e to the power x in minus x into e to the power minus y. So e to the power minus y is taken as common. Okay, e to the power minus y is taken as common, and like one more integral is there, and we may write like this. Okay, let me write it first. In a very simple manner. 0 to infinity, 0 to infinity, and it can be written like ex e to the power minus x e to the power minus y plus y e to the power minus x e to the power minus y dx dy. Okay, this can be written like this, and then we will here when we consider x, then it is a constant term, and then when we consider dy, it is a constant. E to the power minus x is treated as constant. So we will try like integral by parts. It's 0 to infinity e to the power minus y is there, and then we will solve this. Then it comes out to be like 0 to infinity x e to the power minus x dx plus y e to the power minus x dx and dy. First function integration of second. We will try this. Is it okay now? And
Sir, we can also solve this by using gamma property, gamma function.
okay, with the help of gamma function. Okay, how can you elaborate?
Sir,
Is it up to this point? It is okay or not?
yeah, it is also okay, but by the gamma property, the calculation becomes easy.
Okay. Okay, then okay. Just try to solve and give me the answer. No, then
Okay, sir.
yes, try to solve everyone. I'm also trying to solve this. Okay, it is
And the answer is come out to be 2.
what? Answer is comes out to be
2.
2. Like expected value of x plus y is equal to 2. Okay. Can anyone confirm? They have the same answer. Because I have made some mistake, I think. Okay. Please verify this answer. Okay. We will come to the next question. The question number 4 is like the joint density function of a random variable x and y is given by like this. We need to calculate the probability x is less than 0, less than 1 given y is equal to 3. Okay. So please unmute yourself. Sorry. Please mute yourself if you don't. Okay. So fxy is given as like this 6 minus x minus y, or x is 0 to 2 and y is 0 to 2, 0 2 to 4. Okay. We need to calculate probability that x is less than 1 given y is less than 3. That means it can be written as like this: x is less than 1, y is less than 3 divided by y is less than 3. Okay, that means we have a joint distribution, but we first calculate the marginal of y. So marginal of y can be calculated like this. Marginal of y, we will take the range x. It's 1 upon 8, 6 minus x minus y, 3x. Okay, the range of x is from 0 to 2. So it's 1 by 8 is taken as common. It is 6x minus x square upon 2 minus xy, 0 to 2. Is it okay? Now it's 1 upon 8. We will take 6 into 2 minus 2 square upon 2 minus 2y, which is 1 by 8. 12 minus 2 minus 2y, which is equal to 1 by 8. 10 minus 2y, which is equal to 1 by 4. 5 minus y, or y belongs to 2 to 4. Okay, so we will calculate the value of marginal y, marginal PDF of y. Now, the numerator value, probability that x is less than 1 given y is less than 3, which is equal to 1 by 8, 6 minus x minus y. That is double integral 1 by 8, 6 minus x minus y dx dy. Okay. Or you may write dy dx also. So the range of y is 3, less than or equal to 3. So that means it is from 2 to 3. And that means it is from 2 to 3. And x is less than 1, it is from 0 to 1. So it is 0 to 1, 1 by 8, 6y minus xy minus y square upon 2 up 2 to 3 dx is 1 upon 8 integral 0 to 1. When we put the value of 3, it is 18 minus 3x minus 9 by 2 dx upon 8 integral 0 to 1. 18 minus 9 by 2, that is 27 by 2 minus 36 minus 927 by 2 minus 3x dx. And then it is 1 by 8, 27 by 2x minus 3x square upon 2, 0 to 1. It comes out to be 1 by 8, 27 upon 2 minus 3 by 2 minus 0. So is 1 by 8, 7 minus 3, 24 by 2. That is it? Can anyone tell me? I am doing somewhere mistake because my probability comes out to be more than 1. Is 1 by 8, 18, a 9 by 2, 27 by 2. R. Sita Lakshmi, I think you want to say something, but your voice is not audible to me.
Sir, here you only put the value of upper limit, not the lower limit.
Where? Where upper limit?
We integrate with respect to y.
Okay.
Integrate with respect to y.
Great. Here I have considered only
Upper limit, not lower.
sorry. It is 18 minus 3x. Okay. Minus 9 by 2. This is the one thing. And then again minus of. You also need to calculate at x at y equal to 2. Na? That why it is 12 minus 2x minus 2. Now is it okay, I think?
Yes, sir.
So it comes out to be 27 by 2 minus 3x minus 10 plus 2x. 3x, then it is by 8, 0 to 1. And then it is equal to 7 by 2. 7 by 2. Is it okay up to this point? 27 minus 10. That is 7 by 2 minus x. I think there is mistake again, or I think it is fine now. 18 is 9. Okay, 12 minus this 2. Okay, I think it is now fine.
It is
Okay.
good.
Okay, then 1 upon 8 and 7 by 2x minus x square upon 2. We will take 0 to 1. It is 1 upon 8. 7 by 2 minus 1 by 2 minus 0. This comes out to be 1 upon 8 into 6 upon 6 by 2. That is 3. 3. So our answer is 3 by 8. Okay. Again, we need to calculate. I think R. Sita Lakshmi, I'm not able to hear. If you want to say something, then you are not audible. Okay. We also need to calculate probability that y is less than 3. Y is less than 3 means like from 2 to 3, and PDF of y is 1 by 4, 5 minus y. Okay. So 2 to 3, 1 by 4, it's 5 minus y dy, that is equal to is 1 by 4. 5y minus y square by 2 is 2 to 3. It is 1 by 4. 15 minus 9 by 2 minus 10 plus 2, which is equal to 1 by 4 into 7 minus 9 by 2, which is equal to 1 by 4 into 5 by 2, na? 5 by 2, that is 5 by 8. So our required probability that x is less than 3 given, sorry, x is less than 1 given y is less than 3 is 3 by 8 divided by 5 by 8, which is equal to 3 by 5. Is it okay now? I think it is fine now. Okay, question number 5 is the joint density function of a random variable x and y is given as like this. We need to calculate the probability x plus y less than equal to 1. So we will first like make a diagram. Okay, x plus y equal to 2 is like this. This line is x plus y equal to 2. This is like 2 0, and this is like, okay, this is like 2 0, and this is like 0 2. Okay, we need to calculate probability that x plus y is less than 1. That means less than 1 this reason. We need to calculate the probability of this reason. This is 1 0, this is 0 1. Okay, we need to calculate this probability. So taking the step like this, and the probability can be evaluated as 0 to 1, and it is like fxy dx dy. The range of d like x is from this point to this point. It is x plus y equal to 1. From here x is equal to 1 minus y. That means it is from 0 to 1 minus y. Okay, it is from 0 to 1 minus y. Yes. Then 0 to 1, 0 to 1 minus y, and fxy is half dx dy. So first 0 to 1, it is like x by 2, 0 to 1 minus y dy, which is 0 to 1, it is 1 minus y upon 2 dy, which is like 0 to 1, 1 by 2 minus y by 2 dy, and this can be then calculated as y by 2 minus y square upon 4, 0 to 1. That means when we take the value of 1, it is 1 by 2 minus 1 by 4, which is equal to 1 by 4. Okay. The next question is like, if the joint PDF of the random variable x and y is given as like c into e to the power something, find all the parameters of bivariate normal distribution. Okay, it is a normal bivariate normal distribution. Then we need to calculate all the parameters. Okay. So as we have already like if x y follows bivariate normal distribution with parameter mu1, mu2, sigma 1 square, sigma 2 square and rho, then its PDF is like 1 upon 2 pi sigma 1 sigma 2 1 minus rho square t to the power like minus of 1 upon twice 1 minus rho square, and then x minus mu1 upon sigma 1 square plus y minus mu2 upon sigma 2 square minus twice of rho of x minus mu1 upon sigma 1 y minus mu2 upon sigma 2. Yes. So we need to compare this with the standard form, and from here we will calculate like x minus mu is 7. From here like comparing, we will get mu1 equal to like 7, mu2 equal to like minus 5, because it is plus 5 is there, so that means it is minus 5. And after comparing, we get 1 upon 2 1 minus rho square, and then sigma 1 square, it comes out to be 8 upon 27. Similarly, 1 upon 2 1 minus rho square sigma 2 square, it comes out to be like 8 upon 27 into 4. And the last is like 2 rho. So this is first equation, this is second equation. 2 rho upon twice of 1 minus rho square sigma 1 sigma 2. This quantity, from there we will get 8 into 2 upon 27. Question number 3. Okay. And now from these three equations, we need to calculate sigma 1 square, sigma 2 square, rho. Okay. So this can be like from 1 and 2. When we multiply equation 1 and 2, like multiplying 1 and 2. So we get what? 1 upon 4, 1 minus rho square whole square, sigma 1 square, sigma 2 square. Okay. And this is comes out to be 8 into 4 upon 27 into 27. Okay. And then from here, everything is a square kind of thing actually. It is 2 square, it is this whole square, this is square, this is square. Then from here, 1 upon 2, 1 minus rho square, sigma 1, sigma 2. This is equal to like the square root of this quantity, 8 into 8, 64, 64, that like 8 into 2. So that means it is 8 into 2 divided by 27, which is 16 upon 27. Okay. Now we have the value of this. Putting the same value like here in 3. Like from equation 4 in equation 3. So this comes out to be 2 row into the whole quantity, which is 16 upon 27. And this is equal to 8 into 2 upon 27. From here, this is same, this is cancel out, so rho equal to 1 by 2. And when we get the value of rho, we will evaluate, like putting the value of rho in equation 1, we will get sigma 1 square, like 1 upon 2, 1 minus rho square, that is 0.25. Rho is 0.5, square 0.25. Sigma 1 square is equal to 8 upon 27. This implies sigma 1 square is like 27 upon 8 into 2 into 0.75. And after these calculation, it is 27 upon, I think, 12. Okay. 27 upon 12, then 9 and by 4. So it is 9 by 4. And similarly, 1 upon 2, 1 minus 0.25. Sigma 2 square is equal to 8 into 4 upon 27. So simply it is sigma 2 square, which is equal to like 24 upon 8 into 4 into 2 into 1.5, like, and it comes out to be, it is all 1.5, na? And it comes out to be 2 8, 27 upon 48, 48, 16. That means it is around 9 upon 16. So the values are like this, like mu1 equal to 7, 5. Okay, mu1 equal to 7, mu2 equal to -5, sigma 1 square is equal to 9 by 4, sigma 2 square is 9 upon 16, and 2 equal to 1 by 2. These are the parameters of the bivariate normal distribution. And also we need to calculate C actually. So C can also be evaluated. Where can I write? Should I write here? So from here, we will like compare C, and C comes out to be like what? It is 1 upon 2 pi, and sigma 1, sigma 2, 1 minus rho square. We have all values, sigma 1, sigma 2, rho square. So 1 upon 2 into pi into sigma 1 is like, it's 3 by 2. sigma 2 is like 3 by 4 and 1 minus rho square like 0.75. Okay, so like 3 by 4 actually you can write like 3 by 4. It is under root of 3 by 4, like is root 3 by 2. After solving this, we will get c equal to like approximately 0.51 upon pi. Okay, just try to solve this, you will get, and compare the value c from the standard, you will get the value of c from here. Okay. Now the next question is like, if the joint moment generating function of the random variable x and y is like this, then what is the value of the covariance between x and y? Okay. So we need to calculate the covariance. Covariance between x and y is defined as like expectation of xy minus expectation of x into expectation of y. Okay. So first we need to calculate the expected value of x, expected value of y, and expected value of xy. Okay. So like mu1, which is defined like expectation of x, this can be evaluated, not x, is s. This is for x, this is for y. So we need to calculate the expected value of x. Then we will evaluate this with respect to s and put the value of s and t equal to 0. We will go to the expectation of x, that is mxyst. Okay, and then put the value of s and t equal to 0. So that means delta s e to the power s plus 3t plus 2s square plus 18t square plus 12st. Okay. So evaluating this, we will get e to the power like s plus 3t plus 2s square plus 18t square plus 12st multiplied by 1 plus 4s plus 12t. Okay, e to the power these quantity, then e to the power x is equal to e to the power x, and then like suppose e to the power ax like this, and then differentiate this power term, we get this. Now putting s and t equal to 0 0, that means e to the power 0 into 1 into 0, not 0, it's sum, no? That means it comes out to be 1. That means expected value of x is comes out to be 1. In the same manner, like we will hello,
Why 0, 0 is there?
like in when we have moment generating function, okay, then when we want to evaluate the moments like mean variance, the rth order moment, then we differentiate the mgf at the rth time and then put the values of s and t equal to 0, we get the that order moment. So in the similar manner, like we need to calculate the expectation of x. So that means we have already read, na? Wait. Like in univariate case, we have mxt. Okay, given something, and we want to evaluate the second order moment. Then that means we differentiate this mgf 2 times. we need to calculate and then put the value of t equal to 0, we get the second order moment. Okay, in a similar manner, in case of bivariate or multivariate, the MGF is given this, then we differentiate, it is a first order moment, so we differentiate it one time and put the values of s and t equal to 0, 0 to get that order moment. Okay, that's why we have considered s and t equal to 0 after differentiating the joint MGF for one times. Okay.
Okay.
Okay. In a similar manner, like we have calculated expected value of x, we also need to calculate expected value of y. And it is calculated as like y is related to t. That means deba by deba t of mxyst. That means what? Deba by deba t, and it is e to the power s plus 3t plus 2s square plus 18t square plus 12st. Okay. When we differentiate this, we will get like e to the power the same thing, 3t plus 2s square plus 18t square plus 12st. And then multiply this quantity with it's 3 plus 36t plus 12s. Now we put s and t equal to 0, 0. So it comes out to be like e to the power 0 multiplied by 3. That means expected value of y comes out to be 3. Now expected value of xy. That means we need to differentiate okay, and then put value s equal to 0 and t equal to 0. That means like okay. So it is e to the power this quantity which is equal to s plus 3t plus 2s square plus 18t square plus 12st. Okay, so first differentiate this with respect to t, we get deva s, it is e to the power s plus 3t plus 2s square plus 80t square plus 12st. And then multiply this like it's 3 plus 36t plus 12s. Okay, now we need to differentiate this quantity again. Okay, so here with respect to s, we need to differentiate this whole quantity with s. Here, suppose it is like it is first function, it is second function. Here, there is only 12s is there. Okay. So differentiate these again. We will get like first function like these all terms. Differentiation of second function. Okay. Differentiation of second function is like it's 12. Okay. We'll write the whole thing. S plus 3t plus 2s square plus 18t plus 12st. First function differentiation of second function is like 12 plus second function. Differentiation of first function will be like e to the power s plus 3t plus 2s square plus 18t square plus 12st into power term with s, then it comes out to be like 1 plus 4s plus 12t. And then we put s and t equal to 0, 0. We will find out like 0, 0. It's e to the power 0 into 12 plus here 3 k plus this comes out to be 3 into e to the power like 0 into 1. So it is 12 plus 3, which is equal to 15. So our three values are expected value of x is 1, expected value of y is 3, and expected value of xy equal to 15. So our covariance of xy comes out to be expected value of xy, which is 15 upon, minus expected value of x into expected value of y, which is equal to 15 minus 3, which is equal to 12. So 12 is our answer. That is the covariance between the variable x and y is 12. Okay. Now next question is the joint distribution of two random variables x and y is given as like this. We need to calculate expected value of r, expected of xy, and expected value of xy power 2n. Okay. So again, it is joint distribution. So marginal can be written like this. So it is like alpha 1 plus alpha 2 is alpha 3 plus alpha 4, and marginal of y can also be written as like alpha 1 plus alpha 3 and alpha 2 plus alpha 4. That means alpha 1 plus alpha 2 plus alpha 3 plus alpha 4 equal to 1. Okay. Now we need to calculate expected value of x. Okay. Now we need to calculate the expected value of x. So expected value of x is what? It is, since it is a discrete, so x to the power r, probability that x is equal to x. So x equal to from 0 and 1. So when we consider 0, so x to the power 0, or we can say that like x is equal to 0, it's 0 to the power r, and probability that the x to the power 0, okay, and probability that x is equal to 0 plus 1 to the power r, probability that x is equal to 1. So that means is 0 plus 1 into probability that x is equal to 1 is alpha 3 plus alpha 4. This comes out to be alpha 3 plus alpha 4. From here, probability that x is equal to 1 is this. So alpha 3 plus alpha 4 is here. So it comes out to be alpha 3 plus alpha 4. Now again, expected value of xy, it can be calculated as like this. Xy and xy, probability that x is equal to x, y equal to y. Okay. And this comes out to be like suppose we will consider y when we consider y equal to minus 1. Okay. Suppose x into y equal to -1, probability that x is equal to x, y equal to -1. Okay, then plus x, probability y equal to 1, probability that x is equal to x, y equal to 1. Okay, so we will calculate this first. So summation like this, it comes out to be x is equal to x, y equal to -1, x is equal to x, y equal to -1. We will also like put the values of x also. Okay, so it comes out to be like x is equal to 0 and x is equal to 1. So this can be written as like this: x is equal to 0, y equal to -1. Probability that x is equal to 0, y equal to -1, plus x is equal to 1, y equal to -1. Probability that x is equal to 1, y equal to -1, plus x. Okay, x is equal to 0, y equal to 1. Probability x equal to 0, y equal to 1, and plus 1, x is equal to 1, y equal to 1. Probability that x is equal to 1, y equal to 1. Okay, so x is equal to 0, y equal to -1. X is equal to 0, y equal to -1 is alpha 1, and it is 0 because, so it comes out to be 0, plus x is equal to 1, y equal to -1 is alpha 3. X is equal to 1, y equal to -1, so this comes out to be minus of alpha 3, plus here also it is 0, plus 1 into 1, x is equal to 1, y equal to 1 is alpha 4. That means it is alpha 4 minus alpha 3. It is expected value of xy. Okay. And the third one is expected value of xy to the power 2n. Also, again, we will like xy to the power 2n. Then similarly, like 0 into -1, x is equal to 0, y equal to -1 to the power 2n. And probability that x is equal to 0, y equal to -1 is nothing but alpha 1. Okay, plus 0 into y equal to 1, and probability that x is equal to 0 and y equal to 1 is alpha 2. So it is alpha 2 plus it is 1 into -1 alpha 3 power 2n, and then 1 into 1 power 2n alpha 4. So from here it comes out to be 0. This is 0. This is what? Because it is power 2n, that means it is an even number. So that means it is alpha 3. It is alpha 4. And then expected value of xy to the power 2n, this comes out to be alpha 3 plus alpha 4. Okay. Now the next question is like, the joint PDF of a random variable x and y is given by, because these all are actually calculative part only. You only need to calculate this. The joint PDF of the random variable x and y is this: 1 by 4, 1 plus x by y, and the range of x is like mod x less than 1, mod y less than 1. Now, are x and y's are independent or not? So suppose if we are given the joint distribution function fxy. Okay. So if it's so if x and y are independent, then the joint PDF can be written as a product of the marginal PDF. Okay. So this is the criteria for to check the independence of two or more than two vectors, parameters, random variables. So first we need to calculate fx. Fx can be calculated as from y, and it is 1 by 4, 1 plus xy dy, and y is less than mod 1, like it is from -1 to 1. Clear? So that means 1 by 4, it is like 1, it is y plus xy square upon 2. So -1 to 1, this is 1 by 4. So 1 plus x by 2 minus minus of -1 plus x by 2. So after solving this, we will get like 1 by 4, 1 plus x by 2 minus plus 1 minus x by 2. This comes out to be 2 by 4. This is 1 by 2. Okay. So this implies like the marginal of x is 1 by 2. Similarly, we need to calculate marginal of y, which is equal to x from -1 to 1, and it is 1 by 4, 1 plus xy dx, and then it comes out to be like 1 by 4. It comes out to be same, but let's do this. X plus x square y by 2 -1 to 1. It is again the same quantity. After calculating, we get fy of y equal to 1 by 2. Now, for two random variable x and y to be independent, we need to fx into fy, which is equal to 1 by 2 into 1 by 2, which is equal to 1 by 4, which is not equal to the joint PDF of 1 by 2. That means not independent. Clear? If these conditions satisfy, then it is independent, otherwise it is not independent. Okay, now next question is like, if x follows bivariate normal with mean like this, parameter value is this, we need to calculate the expected value of this, and variance is this. Okay, as we will already discuss, like suppose xy bivariate random variable, then its conditional distribution is also a normal variate. Suppose if xy follows bivariate normal distribution with mu1, mu2, sigma 1 square, sigma 2 square, and rho, then like y given x, y given x equal to x follows normal distribution with mu 2 plus rho sigma 2 upon sigma 1 x minus mu1. This is the mean value, and sigma 2 square 1 minus rho square. This is the distribution that y given x variable follows. So calculating this, like mu1 equal to 3, mu2 equal to 4, sigma 1 equal to 4, sigma 2 equal to 5, and rho equal to 0.8. That means expected value of y given x equal to 5 is okay. Wait, no need to calculate this then y given x equal to y follows normal distribution with mu2 equal to 4 plus 0.8 into sigma 2 is like 5, sigma 1 is like 4, x is like 5 because it is given x is equal to 5, minus mu1 equal to 3, and variance is like sigma 2 square. Sigma 2 square is like 25 and 1 minus 0.8 square. So this means x follows like 4 plus this comes out to be 0.2. It comes out to be 2 actually only. Because 0.8 divided by 2, 0.2 into 5, 1, and 5 minus 3 equal to 2. And it is 25, 1 minus 0.64, like which is normal 6, and it is 25 into 0.36, and this comes out to be normal 6 and 900. That's sorry, 9. That is. So that means, and we know that if a variable follows normal distribution with the given value of parameter, then expected value of this is the first one, which is 6, and variance of is the second one, which is 9. Is the answer. Okay. Now the next question is like, let the joint PDF of a random variable x and y is given by 8xy and xy lies within this. We need to calculate the value of expected value of x plus y given y, sorry, y given x is equal to x. Okay. So, okay. So first, for expected value of this, we need to calculate like what? Okay. I forgot to like wait. Okay. So y given x, then first we need to calculate like PDF of y. Okay. Y given x. We need to calculate the PDF of y given x. So that means it is joint PDF divided by like marginal PDF. Okay. So joint PDF are given 8xy. We need to calculate the marginal of x first. So marginal of x is defined as like y and 8xy dy, and the range of y from here, range of y comes out to be from x to 1, from x to 1. That means 8 x is taken as common, which is y square by 2 from x to 1. This is 8x, and it is 1 by 2 minus x square by 2, and it comes out to be 4x minus 4x cube. It is 4 is x minus x cube. This is the PDF, na? Or 4x 1 minus x square. Okay, so This is the marginal of x. Now, y given x is 8xy, which is the joint of this, and marginal is like this 4x 1 minus x square. It comes out to be 2y upon 1 minus x square, or this range. Okay, 2y upon x is 1 minus x square. Now, the expected value of y given x is equal to x is y range, which is from x to 1, then y multiplied by 2y upon 1 minus x square dy, which is 1 upon 1 minus x square, and 2 upon 1 minus x square is taken out here, and y square to y power 3 upon 3 x to 1, which is about 2 by 3 1 minus x square. It is 1 by, it is like 1 minus x cube. So this comes out to be 2 by 3 1 minus x cube upon 1 minus x square. Is it okay? Okay. And the next question is like, let the joint PDF of random variable x and y is given by 1 by 3 x plus y. X ranges from 0 to 2, y from 0 to 1. We need to calculate the correlation coefficient between x and y. Okay. So correlation coefficient again. It's correlation coefficient between the variable x and y. It is defined as like covariance between x and y, and divided by sigma x, sigma y. Correlation means like to check the linear association between variables. So now covariance of xy, it is calculated like expected value of xy minus expectation of x, expectation of y. So for expectation of x, we need the marginal of x. Expectation of y, we need the marginal of y. Okay, so start with the marginal. So fx of x, which is equal to y range, which is from 0 to 1. It is from 0 to 1. Okay, it's 1 by 3 x plus y dy, which is equal to 1 by 3. So xy plus y square upon 2, 0 to 1, that means 1 by 3. Like putting the value of y, it is x plus 1 by 2. Or we can simplify it like this, x by 3 plus 1 by 6. That means 2x plus 1 by 6. Okay. For x equal to 0 to 2. In a similar manner, fy can also be calculated from 0 to 2. 1 by 3 x plus y dx, which is equal to 1 by 3 x square by 2 plus xy 0 to 2, which is equal to 1 by 3. Putting the value of 2, it comes out 2 plus 2y minus 0. That means 2, like simply can write like this, no? It is 2 by 3 1 plus y. For y equal to 0 to 1, here it comes out to be y. Okay, so PDF like marginal of x is this, 2x plus 1 by 6, and marginal of y is 2 by 3, 1 plus y. Okay. Now expected value of x, expected value of y, and then expected value of xy, and then also variance of x, variance of y is also we need to calculate. So first, expected value of x, which is like 0 to 2 x into marginal of x, which is equal to 2x plus 1 upon 6 dx. So it is 1 by 6, 0 to 2, 2x square plus x dx, which is like 2x cube by 3 plus x square by 2, 0 to 2, which is equal to like 2 to the 2 into 2 to the power 3 divided by 3 plus 2 square by 2 minus 0. This is like 16 upon 3 minus 2. So expected value of x is like 1 by 6.
Plus 2.
Okay. Sorry. First two is there. So that is like 1622 upon 3, which comes out to be 11 upon 6. Sorry, 11 upon 9. This is the expected value of x. Similarly, expected value of x square. So expected value of x square is like 0 to 2 x square 2x plus 1 by 6 dx, which is equal to 1 by 6 is there. That means it is 2x. Okay, right again. It is 2x cube plus x square dx, which is equal to 1 by 6. It is 2x to the power 4 upon 4 minus x cube upon 3, 0 to 2. That means 1 by 6. So 2 to the power 5, that comes out to be 16 actually after solving.
Here again you write minus sign.
Sorry. Okay. Is it okay then? Now it is 8 upon 3
Yes.
is 1 upon 6 into. Now is it okay now? So 1 upon 6 into, it comes out to be like 56 upon 3. This comes out to be 28 upon 9. Okay. Think is it right? Na? We put the value of x is equal to 2 here. So 5 upon. Okay, there is one more mistake actually. It is there 4. Na? So this is not 16. This comes out to be like 2 to the power 4 is 16. 32 divided for 8. It's 8 plus 8 by 3. This comes out to be like 1 by 6 multiplied by 32 upon 3, which comes out to be 16 upon 9. Okay. So this is the expected value of x square. Now variance of x is expected value of x square minus expectation of x, which is like 16 upon 9 minus 11 upon 9 square. 16 minus 9 minus 1 to 1 upon 81, which is equal to 81. 144 minus 121, which is comes out to be like 23 upon 81. This is the variance of x. In a similar manner, we will calculate the variance of y. Okay, an expected value of y, since I have already calculated. So let me write this like this. Expected value of y is 0 to, okay, y ranges from 0 to 1. 0 to 1, y into the marginal of y is calculated as 2 by 3, 1 plus y. 2 by 3, 1 plus y. And after solving this, like you people may solve this. Okay, 0 to 1, and it is y plus y square dy, and then it is 2 by 3. It is y square by 2 plus y cube by 3, 0 to 1. And the expected value of y comes out to be like 5 by 9. Okay, please solve this. You will get expected value of y equal to 5 by 9. In a similar manner, expected value of y square, this comes out to be like 0 to 1, y square 2 by 3, 1 plus y dy, which is 2 by 3. Okay, and it is 0 to 1 is y square plus y cube dy, which is equal to 2 by 3, which is y cube upon 3 plus y to the power 4 upon 4, 0 to 1. And after solving this, you will get expected value of y equal to like it's 5 by 9, not 5 by 9, it's like 7 upon 18. And then variance of y is calculated as 7 upon 18 minus 5 by 9 square. And it comes out to be 13 upon like 162 after solving this. Okay, so we have sigma x, sigma y, expected value of x, expected value of y. Now expected value of xy is also there. So expected value of xy is what? Like it is double integral x from 0 to 1, y from 0 to 2, and the marginal PDF is like, the marginal PDF is given like 1 by 3 x plus y. 1 by 3 x plus y dy dx. Okay, so first integrate with respect of y, all this, and then again integrate with respect of x. We will get expected value of xy, which is comes out. Yes.
The xy is also multiplied by
Yes.
TDS now.
Yes. Xy, because we need to calculate the expected value of xy. So xy and joint of fxy. Okay. So after solving this, you will get like 2 by 3 actually. Okay. And then we need to calculate the correlation between x and y, which is equal to covariance between x and y and sigma x, sigma y. And covariance will be written like expectation of xy minus expectation of x, expectation of y, and sigma x, sigma y. So expected value of xy is like 2 by 3 minus expected value of x is 11 by 9. Expected value of y is 5 by 9. And then sigma x is like 23 upon 81 under root of 23 upon 81, and sigma y is like 13 upon 162. And after calculating this, you will get it approximate value of this is like minus of 0.0818. Okay, that means the variable x and y is negatively correlated. That means if one is increasing, then the other variable is decreasing, and vice versa. Okay. Now the 13th question is like the joint density function of a random variable x and y is given by this. The value of x and y, the range of x and y is given this. we need to calculate the expected value of x given y equal to 2 and okay. So again, we need to calculate the expected value of x given y equal to 2. That means first we need to find expected value of x given y, the PDF of x given y, which is equal to like joint divided by marginal of y. Then our first aim is to calculate the marginal of y, which is what? Expected value of, like we will take the range of over x. So from 0 to infinity, 1 by 2 y to the power minus xy dy. It's dx, na? Dx. Okay. So this can be calculated like 1 by 2 y is taken as common. So e to the power minus xy and then minus of y 0 to infinity. And this comes out to be 1 upon 2y. X is equal to infinity and minus is also there. So minus of e to the power minus infinity and minus minus plus e to the power minus 0. So that means what? Fy comes out to be like 1 by 2 because this y cancel out to be this y and the range of y is 0 to 2. Okay. Now the conditional of x given y is y equal to 2. Actually it is already given. Let's first write the general form. So it is 1 by 2 y e to the power minus xy divided by 1 by 2 comes out to be like y e to the power minus xy or x greater than 0 and y belongs to it's 2 to 4. Okay. So fx y equal to, like we need to calculate y equal to 2. That means 2 e to the power minus 2x. Okay. If you recall, if you may recall, like this is what? Suppose if x follows exponential lambda, then fx is equal to lambda e to the power minus lambda x. And after calculating here, we get lambda equal to 2, and it is the exponential distribution actually. Okay, so that means it is the exponential distribution. So you may either solve this with the usual method like expected value of x given y equal to 2, which is like integral over x, like from 0 to infinity, and x into 2 e to the power minus 2x dx. Or you may already know that in this case, the expected value of x is nothing but 1 by lambda, or variance of x is nothing but 1 by lambda square. So it comes out to be like 1 by 2 when we solve this. So you may use this relation, the univariate exponential distribution. So it is 1 by 2 and variance of x is variance of x given y equal to 2 is like 1 by lambda square, which is equal to 1 by 4. And expectation of x square. We need to also calculate expected value of x square given y equal to 2. This is equal to like variance of x given y equal to 2 minus, sorry, plus expected value of, sorry, not plus, like we know that this formula, variance of x is equal to expectation of x square minus expectation of x whole square. So we need to calculate this, which is variance of this plus this. So plus expected value of x given y equal to 2. So it is 1 by 4 plus,
The whole square expected value.
yes, whole square. So it is 1 by 2 square. And this comes out to be 1 by 4 plus 1 by 4 equal to 1 by 2. So that means expected value of x square given y equal to 2 equal to 1 by 2. Okay, so you may solve with the usual method also, or you may solve directly, because we know that it is the PDF of exponential distribution with parameter. Okay, similarly, this also a question like let the joint PDF of a random variable x and y is given by kxy, the range of this. We need to calculate the value of k and the correlation coefficient between them again. So first, for this to be a like joint PDF, so we will take integration from 0 to 1, from 0 to 1 kxy 1, so 0 to 1 k. So kx is y square by 2, 0 to 1 dx is equal to 1. This is 0 to 1 kx is 1 by 2 equal to 1. That means like k by 2, it is x square by 2, 0 to 1 equal to 1. From here, we will take k equal to 4. After solving this, you will get k equal to 4. Very simple. Okay, so we have k equal to 4. That means our PDF is like this: 4xy for x belongs to 0 to 1 and y belongs to 0 to 1. Okay, now we need to calculate again the correlation coefficients. So correlation coefficients between x and y is covariance of xy and divided by sigma x sigma y. Again, covariance of xy can be evaluated like expected value of xy minus expected value of x into expected value of y. Okay, and for this we need to calculate the marginal PDF of x and y. So from here, like fx, which is equal to I, which is from 0 to 1 4xy dy, which is equal to 4x. It is y square upon 2 0 to 1. This comes out to be 2x for this, and y equal to, in the similar manner, 4y. It is x square upon 2 0 to 1, which is 2y. Here, if you see, like the marginal of x is 2x, marginal of y is 2y, and the joint is like 4xy. So, like here, we see that fx into fy, which is equal to 2x into 2y, which is equal to 4xy, which is equal to f of xy. This implies x and y are random variables. X and y are independent random variables. Independent random variables. That means the covariance between these two terms comes out to be 0. And this implies correlation between x and y, which is equal to covariance between x and y, and divided by sigma x, sigma y, comes out to be 0. So either you may solve all these quantities, expected of x, expected value of y, sigma x, sigma y, and put these value, and you find out the correlation is 0. Or you may directly, by using the independence property, you may check since x and y are independent. If two variables are independent, then the correlation coefficient is 0. But if the correlation coefficient is 0, that does not imply it is infinite. Okay, because correlation coefficient gives the linear association. Okay, suppose y equal to x square is there. In that case, it may possible the covariance correlation coefficient is 0, but here y is totally dependent on x, na? But it is not linearly dependent, and the correlation coefficient gives the linear dependence. Okay. Now the last question, which is like the joint PDF of a random variable x and y is given by 2. We need to calculate the expected value of this and variance of this. Okay. So like, okay. Again, we need to calculate expected value of x given y. So first we need to calculate, okay, like f of x given y, and for this x given y, we need to calculate like fxy upon fy. Okay, so fy is something like this. It is fy, which is x. X ranges from 0 to y. Okay. X ranges from 0 to y. That means 2 and dx. This comes out to be x 0 to y, which is equal to 2y, or y belongs to 0 to 1. Okay. Now our aim is to calculate f x given y, which is equal to 2 upon 2y, which is equal to 1 by y, or x belongs to 0 to y and y belongs to x2. Okay, so we have the distribution 1 by x. Now we need to calculate the expected value of x given y equal to 1 by 2. So at y equal to 1 by 2, okay, now first x y equal to 1 by 2, it is like 2, na? Y equal to 1 by 2. So that means it is like 2. Okay, 0 to 1 by 2. Okay. So now we need to calculate expected value of it, which is equal to integral over 0 to half x into like 2. So it is x square by 2, 0 to half. And this comes out to be like 2 cancel out. It's 1 by 4. So expected value of x given y equal to half is like 1 by 4. And also variance. For variance, we need to first calculate like expected value of x square given y equal to half minus expected value of x given y equal to half whole square. Okay, so that means expected value of x square given y equal to half is like 0 to half x square into 2 dx, which is equal to 2 x cubed by 3, 0 to half. So this comes out to be 2 by 3. It's 1 by 8 minus 0. This comes out to be like 1 upon 12. So variance of x given y equal to half is 1 by 12 minus 1 by 4 square, which is equal to 1 by 12 minus 1 by 16. 48, 4 minus 3, which is equal to 1 by 48. Okay. So I think that is it. So if anyone have any doubt, they may ask. Anyone? Okay, am I audible now?
Yes, sir.
Okay, thank you. So if there is no doubt, then I think we should conclude here then. Okay, then let me stop the recording first.